Hi there, welcome to my channel Mando to Fundo. In this video, I'm going to discuss about the solution for summarizing the ranges in the given input array. Let's look at the problem description. So we are given a sorted unique integer array nums, and then a range a comma b is a set of all integers from a to b inclusive. So we will have to return the smallest sorted list of ranges that cover all the numbers in the array exactly. So each range a comma b in the list should be output as a arrow b if a is not equal to b, and otherwise if a is equal to b we have to just simply give only one number for that. So let's take a look at the example 1. We have a nums input array which has 0 1 2 4 5 7. So in this is consecutive and there is a gap, 3 is missing, so we have to summarize them as 0 to 2, and then 4 5 and there is a gap between 5 and 7, so we have to summarize 4 and 5 together, 4 to 5, and then this is the leftover, so only 1. Okay, so then array length will be ranging from 0 to 20 and the value will be minus 2 power 31 to 2 power 31 minus 1, and all the values of nums are unique, and the nums array is sorted and in ascending order. Let's look at the approach to solve this problem. So we have this input and the output will be like 0 to 2, 4 to 5 and 7. So basically we use 3 pointers. 2 of them start and end tracks the current range that we have seen so far, and then the third pointer idx will be used to iterate over the input array. Okay, so first we initially make the start and end pointer to point to the first element in the array, and then we read the rest of the element in the array starting from the index 1. Okay, so on each iteration we compute the difference between those two numbers. If that value is greater than 1, that means there is a gap between these two numbers, otherwise they are consecutive. If 0 and 1, then the difference is 1, 1 and 2 difference is 1, but 2 and 4 the difference is 2. So if it is greater than 1, there is a gap, so we have to compute the difference. If the difference is exactly equal to 1, we simply advance the end of that current range by 1. We keep doing that until we see the difference is greater than 1. For example, in this case the end index will be moved forward until this point. When we read this value, there is a difference 2 which is greater than 1. So what we do immediately, this between the value start and end we form a range like this. We will write it in the output list, and then we reset the start and end index to the current idx. Now the start and end point to number 4. So like that it will go until we reach the end of the array. So when we reach the end of the array, we will see the output like this. Let's look at the flowchart. Input for this procedure is the nums array, which is in a sorted order, and each elements are unique. So first we initialize the start and end index to 0 and initialize the output list, and then initialize the index variable to the index value 1, and we compute the length of the array and assign that to count. First we check for the edge case whether we have an element with single. First we check whether the given input array is of size 1. If so, we simply write that nums to the output list and then return that value. Otherwise we enter the for loop. Here we compute the difference between the current element pointed by the IDX index and the previous element IDX minus 1. And if the difference is greater than 1, that means the range is broken. So we write the current range to the output list, and then we set the IDX value to start and end pointer for the next range that we are going to encounter. If the difference is exactly equal to 1, we simply increment the end pointer of the current range. Okay, so the range is growing. Then we also check whether the current element is the last element of an array. Okay, so if so, whatever the current range we have seen so far, we write that to the output list, and then go and increment the index, which will we eventually this condition will be false after processing all the elements. Then we come out of that loop. So finally the output list contains the summarized range for our input array. Let's move on to coding. First I initialize the output list. Then the count variable, which will have the number of elements in the input array. And first I check whether the input array is empty. If so, I will return the empty output list. Next I check whether the input array has only one element. In that case, I convert that single integer into a string and add it to the output list and return it. Then I initialize the start and the end pointer of the current range to 0. Basically it is both pointing to the first element of the array. Then I start the for loop, which process the element from the index 1 to the end of the array. In each iteration I compute the difference between the current element pointed by the IDX and in each iteration I compute the difference between the current element pointed by the IDX and its previous element, and if the difference is greater than 1, that means we are out, the range is broken, so we have to write the current range into the output list. So I am calling the write data function to write that current range, passing the current start and end, and then the nums input array, and then the pointer to the output list. Then I update the start and end indexes so that they point to the current element, which is the beginning of new range. Otherwise I simply advance the end pointer, so the range is increasing in that case. Then at the end then I check whether the current element is the last element of the input array. In that case I write the current range into the output list. So in that case I am writing the current range into the output list. Finally, I return the out list. Next, I'm going to implement the write data function, which actually convert the nums array, part of the nums array, into a range string and add it to the output list. First, I count the number of elements in that range, including start and end index. So end minus start plus 1 will give that. And first, I convert the integer pointed by the start index into a string. If the count is greater than 1, that means we need to add the end number also. So I append the arrow plus the end number will be converted into a string, and then that also gets appended to the initial string. Then I added the str into the out list. Next, I am going to run the test cases. Okay, all the tests passed. Next, I am going to submit this program. Cool, this program is accepted. Next, I am going to do the code walkthrough with sample input. So we are given this input and the expected output is this. Okay, first we compute the count, which is for this case it is 6. So this condition will be false, and then we initialize the start and end index to 0. So they both point to the first element of an array. Okay, and then the idx is starting from the second element of an array. Okay, so in each iteration we compare this value with the previous value, and if that difference is greater than 1, then we write, otherwise we simply increment the end pointer of the current range. Okay, so in this case 1 minus 0, which is equal to 1, so we simply increment the end pointer by 1. So the end pointer is 1 and the starting pointer remains in the same place. So on the second iteration, same thing, the idx points to the number 2, and it compares with the previous value, that it compute the difference between the previous value. It is still 1, so we simply advance the end pointer. So that's what we are seeing here. So starting is 0 and end pointer is moved to 2. On the second iteration, the idx is pointing to the number 4th element, and the value is 4, and when it compute the difference between this and the previous value, it is 2. 4 minus 2, 2, which is greater than 1. So we hit this condition, so we write the data to the out list. So what is the current range? 0 to 2. 0 to 2 is the current range that will be added to the 0 to 2 will be added to the out list. and then after adding it we update the start and end pointer to point to the current IDX. So current IDX is 3. So start and end pointer will be updated with the 3. So they both, so this is the next range we are going to deal with. And then on the iteration 3, the IDX moved to the 5th index, and the difference between the 5 and 4 is 1. So we simply advance the end pointer. So now the end pointer points to the 5th element of an array. And on the last iteration, IDX points to the last element of an array, and we compute the difference between the previous value and the current value, which is 2. Then we write the current range, which is ranging from index 3 to 4, which is 4 and 5. So what we are doing, so we will be writing 4 to 5, and then we are writing that, and then we come to this part where the current IDX plus 1 is equal to count. So the current IDX is 5 plus 1 equal to 6, which is the number of elements in the array. So we are checking the last element condition. So in that case, whatever the start and whatever the current range, we write that to the out list. So in this case only one element in the current range, so we added that 7 as well. Finally we get the expected output. Next I'm going to do the time and space complexity analysis for this solution. So let's do the time complexity analysis for this input. So for this input, how many times this for loop will execute? So it's 1 less than the number of elements in the array. So in this case 6 minus 1, 5. So this loop executes 5 times. Okay, so in general for input array with n elements, it will be n minus 1 times, so which is order of n times. So the time complexity is order of n. And with respect to the space complexity, it is order of n as well, because depending on the nature of the input, the amount of space will vary. For example, in this case we have 6 elements, but the output have 3 strings because some part is consecutive and some is not. So for this case we need space for 3 elements. Assuming the case where all the elements are not consecutive, for example this is 0, 3, 5, 8, 20, 30, something like that, then the final output will be for each number there will be an one entry like this 7. So finally we have to have space for n number of elements. So that's why the space complexity for this solution is order of n. Thanks for watching this video. Have a great day.